There are some quadratic equations that are not perfect squares and they cannot be factorized. So since they are not perfect squares and they cannot be factorized, we try to make them perfect squares. So that brings us to making quadratic expressions perfect squares. Now, and to make them perfect squares is to ensure that the first and the last term are said to be perfect squares, while the middle term is said to be twice the square root of the product of the first term and the last term. And how is that possible? We shall see that in the next example. Example says we should find the terms that must be added to the following quadratic expressions to make them perfect squares, then factorize completely. Now, these are said to be quadratic expressions, but they are not perfect squares. So the question is, we should find the terms that must be added to make them perfect squares. Solution. A is x squared plus 12x. For us to make this a perfect square, something must be added. Let's call it k. So let's say plus k. That x squared plus 12x plus k is equal to x squared plus 2xy plus y squared. Now, by comparing coefficients, we have it that x squared is equal to x squared. That I'm comparing the first term with the first term. Also, the second term, which is plus 12x, is equal to 2xy. And when you divide both sides by 2y, you divide here by 2x, you equally divide here by 2x to get our value for y. You have it that y is equal to 6. So if y is equal to 6, comparing the third term, we have it that k is equal to y squared. And y has been gotten to be 6. It therefore means that k is equals to 6 squared. And 6 squared is equal to 36. So it therefore means that 36 must be added to x squared plus 12x to make it a perfect square. And when you do that, you agree with me that it's a perfect square, because this becomes x squared plus 12x plus 36. And the question says we should then factorize completely. So factorizing this, we have x squared plus 12x plus 36. This becomes x squared plus 2 into 6x plus 6 squared. So that when you factorize it, it becomes x plus 6 all squared. So this is how you can make quadratic expressions that are not perfect squares perfect squares. So let's take the next example, which is b. B is 2m squared minus 3m. What must be added to this to make it a perfect square? Let's call it k as usual, to be equal to, because we are dealing with m, I'm going to use m squared minus 2my plus y squared. And by comparing coefficients, before we compare coefficients, it is advisable that the first term must be a perfect square. So I'm going to divide both sides by 2. So you have m squared minus 3 over 2m plus k over 2 is equal to m squared minus 2my plus y squared. because the first term must be a perfect square. So for us to make it a perfect square, I have to divide both sides, every term, by 2. Now, by comparing coefficients, you agree with me that m squared is equal to m squared, and minus 3 over 2m is equal to minus 2my, dividing this, and when you divide this by minus 2, this now becomes my plus 3 over 4 is equal to y. So y is said to be 3 over 4. Now, if y is equal to 3 over 4, compare the last term, you have k over 2 is equal to y squared, but we have y to be 3 over 4. So this means that k over 2 is equal to 3 over 4 squared, and k over 2 is equal to 9 over 16. K is equal to, you multiply both sides by 2. K is said to be 9 over 8. So if k is equal to 9 over 8, it means 9 over 8 must be added to this. So we have it as okay, since the last term is k over 2, as in this case, so we add it up, and k over 2 is 9 over 16. So this becomes m squared minus 3 over 2m plus k over 2, which is 9 over 16. So we need to multiply the whole term back by 2 to get back to the original expression. This becomes 2m squared minus 3m plus 9 over 8. So what this means is that 9 over 8 must be added to 2m squared minus 3m to make it a perfect square. And the question says, hence, we should factorize completely. So factorizing this completely, we must equally ensure that the first term and the last term is a perfect square. And for us to make it a perfect square, we therefore need to divide all through by 2. So this gives us m squared minus 3 over 2m plus 9 over 16. And when you factorize, we are going to write it in the form of x squared minus 2xy plus y squared. So this is already m squared. When you factorize out 2 from here, you have minus 2 into bracket 3 over 4m plus 3 over 4 squared. So that this now becomes m minus 3 over 4 all squared. Definitely it's going to be a minus because the middle term is a minus. So this is how you can make a quadratic expressions a perfect square. So having known how to make quadratic expressions perfect squares, this is going to guide us in completing the square method. So let's look at completing the square method.